Hello everyone. So in this chapter we are going to talk about disk storage, basic file structure and hashing. So the database management system stores a lot of data. The data amount can be huge. Okay. So when the data size is really large, so the preferred storage device is the secondary storage device. Okay, because the secondary storage device can have high storage capacity, and our data size for the database, it can be really high. All right, so it can be really high, so we cannot store all the data all the time in our main memory. All right, so that's why the preferred secondary storage device is the uh, secondary storage, because there is high storage capacity and the low cost. Okay, now in this chapter we are going to actually talk about the disk storage, how the database management system actually manages this disk storage, and what is the basic file structure. So all the data actually stored as a magnetized area on the magnetized disk surface. So there is a disk pack that contains several magnetic disks, and each of the magnetic disks are connected to a rotating spindle. So each of the disks that are divided into concentric circular tracks on each disk surface. So a disk surface looks like that. Okay, this is looks like a disk surface. Okay, and in each disk surface they are divided into some other concentric circular track. So this looks like that. Okay, so these are actually like not a physical circular concentric circle, it's actually some logical circle. Okay, means this circular track is divided some other circular track. So each of the division here, they are known as track. So this one is, let's see, track 0, this one is track 1. Okay, this one is track 2, like that. Okay, so track capacity can be vary, so each of the track can have different capacity, and it can be very typically 4 to 50 kilobytes, or it can be more than that. Okay, so each of the track is again divided into smaller block or sector. So how does that look like? Okay, so each of the track is again divided by some sector. All right, so this is sector 1. Let's see, assume this is sector 1, this is sector 2. Okay, the whole sector 2, this is sector 3. Okay, so here you can see that each of the disc, I mean each of the circular face, is divided into some track and sector. Okay, now you can see actually here I have some division here, like that each of the record are actually stored in this division. So for example, this area. Okay, now if I think about this area has a specific sector and a track. Okay, so if this is say track 0, this is track 1, track 2, track 3. Okay, and this is sector 1, sector 2, sector 3, sector 4, 5, 6. Okay, so this area here, it has like a address. Each area here, each division or area will be actually identified by address with a track number. Okay, track 0, 1, 2, 3, track 3, sector 6. Okay, that's how I will know that this means this area. All right, or let's say this area, that means this is track 2, sorry, track 1, it should be track 0, so that should be track 1. track 1 and sector 1 2 3 4 5 6 7, sector 7. Okay, so this division on the track into sectors, it is actually hard coded, and on the and it cannot be changed. Okay, so generally sometimes it also done by the manufacturer actually hard codingly done this division, like divide a track into sectors. Okay, so one type of sector organization calls a portion of track that subtends a fixed angle at the center as the sector. Okay, like that. Now a track is divided into block. Okay, so each of the area that I am talking about, this area, okay, this area or a specific area, here you can see that by using the address of sector and track, this is known as a block. Okay, so each block, we are going to use the capital B to denote each block. Each block has a fixed size. Okay, so typically the block size can be 512 byte to it can be also 4096 byte, and sometimes it also depends on the manufacturer will decide what will be the size of block. Okay, so this is very important that whole blocks are transferred between disk and main memory for processing. So what do we mean by that? So when we say that whole blocks are transferred between disk and main memory for processing. Alright, so this is our circular disk look like. We have some tracks, some sectors, and each track is divided by some block. Okay, so let's see. Okay, so let's see, this is one block, this is another block, like that. Okay, all right, so each of the record, okay, so each of the record will be stored in this block. For example, let's say this is one record. Okay, so this is one record R, this is one block, let's say B1. Okay, so the record R1 is stored in block B1. Okay, all right. Now to make it a faster processing, what actually we do, when we need to process a specific record, for example we want to fetch the record, or we want to insert a record, or we want to update the record, like for any kind of processing, what we have to do, we have to actually fetch the record in the main memory. Okay, so this is our secondary storage. So if we write a program, I mean if we want to access something, okay, we cannot actually access anything directly from the secondary storage. Means actually if we write a program, our CPU, alright, our program cannot directly access anything from the secondary storage. Each of the program, before accessing any kind of data, it has to fetch the data from the secondary storage to the main memory. Okay, that means now if I want to fetch the record R1, okay, let's say my program needs the record R1, means I have to actually fetch the record R1 from the secondary storage to the main memory. Now in the DBMS system, what it does, it actually fetch the whole blocks. Okay, for example, if I need R1, I am not going to actually the database system is not going to fetch only the R1 into main memory. What it is going to do, it is going to fetch the whole block, okay, the whole block B1 to the main memory. Okay, then from it is going to record, it is going to work with the record that it may need. Alright, for example R1, it is going to work with the R1, or if it needs any other record from that block, it is going to work on that. Okay, so after you are done with your data, you are going to actually push it back, you are going to keep that back in your secondary storage. Okay, you are going to delete everything, you are going to free your records space in your main memory, because actually the storage size in your main memory is always limited. Okay, and it's a volatile, means we cannot actually keep things stored in our main memory. All right, so that is the idea. Whenever we are going to we have to transfer something, we are going to transfer the whole block. So this is the example. So this is an example of a circular disc. All right, so these are the track. All right, and in each of the track we have couple of sector. Okay, so in the disk storage device, how to find a specific record or block? As we are saying that whenever we have to work with a record, we have to fetch that record, means we have to fetch the whole block where the record is. Okay, now how to find that record or how to find that track? Okay, so there is actually a read write head that moves to the track that contains the block to be transferred. So you can see in this picture, in this example, you can see that here we have a read write head. Okay, so this is the spindle, okay, that will rotate. All right, and then there is another read write head that is going to actually find out the specific track. Okay, moves to the track, and that is going to find the specific track that contains the block that has to be transferred. Okay, so this disk rotation moves the block under the read write head for the reading and writing. So each of the physical disk block, we are talking about the disk block, means we have to actually fetch the record by fetching the block. So how to find a specific disk block? Each disk block will have a address, and that address will consist of these following things: a cylinder number. Okay, so a cylinder number means actually like it's a imaginary collection of track of same radius. So a cylinder number means actually simply it's the track number. um, um, so so that's not actually track number, so that's a cylinder number. Then there will be a track number and a block number. Okay, so with this combination of these three information, the cylinder number, track number and block number, that will give the address of a specific disk block. Okay, now reading writing a disk block is time consuming because of the seek time s and the rotational delay. All right, so there could be a double buffering can be used to speed up and transfer of the contiguous disk block. So that's it. A typical disk parameter looks like. Here you can see that each disk block means most of the things are determined actually by the manufacturer and like hard coded. Okay, say for each disk block there is a model number, height, width, length, width, capacity. Okay, and there are some transfer rate will determine the performance. All right.